How many ways can I choose 3 different numbers from the digits 1 through 9 such that the sum of these 3 numbers is a multiple of 3? Alright, so we've got to choose 3 digits from 1 through 9. So let's list them out. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so these are our options. And we have to choose 3 different ones. Okay? So it says 3 different numbers. And we're looking for the cases where the sum of these 3 numbers is a multiple of 3. Okay? So, obviously if all of the numbers are multiples of 3, like for example, if we take 3, 6, and 9, then obviously the sum is going to be a multiple of 3, right? Because if you add a multiple of 3 to a multiple of 3, you get a multiple of 3, right? There are cases, like for example 1, 2, and 3. Now, only 3 is divisible by 3, but 1, 2, and 3 gives you 6, and that's divisible by 3. So, I'm going to show you a trick to make these problems a little easier. Let's look at the remainders when we divide by 3 of these numbers, okay? So when we divide 1 by 3, okay, it goes into, there's 0 3's, and then we have 1 left over, so the remainder is 1. Same way with 2. We have 0 3's, and we have 2 left over. Now when we divide 3 by 3, we have nothing left over, right? It just goes in once. And then the remainders cycle around again, right? So this is 1 3 plus 1. This is 1 3 plus 2, and this is 2 3's, so we have no remainder. And again, they cycle around again. So this is 2 3's plus 1, 2 3's plus 2, and then we have 3 3's, which has a remainder of 0. Okay, so we can classify these numbers into groups according to the remainder. All right, and the other thing to know is that if we add numbers up, you're adding, every number is a multiple of 3 plus a remainder, right? So if all the remainders add up to a multiple of 3, then it's going to be evenly divisible by 3. Say, for example, if I take 6 and 7 and 8. So this is 2 3's, 2 times 3. This is 2 times 3 plus 1, and 8 is 2 times 3 plus 2. And you can see the remainders, here's our remainders, they add up to 3. So we're going to get something that is divisible by 3, because the remainders end up adding together and completing essentially a multiple of 3. So we end up with what, 2, 4, 6 sets of 3 plus 3 more, which ends up giving us 7 times 3. So if you add this up, you'll get 21, right? So if we're looking for the sum of the numbers, we want the sum of the numbers to be a multiple of 3, right? So what we want is for the remainders to add up to 3, which ends up giving you a multiple of 3. Okay. So let's look at the different cases. One case I think I mentioned first off, if we have a remainder of 0, that means it's a multiple of 3. So if I take 3 multiples of 3, I'm going to call that an R0 number. Okay. If I add 3 multiples of 3, that gives us a multiple of 3, right? So let's take that case first. And the only multiples of 3 are 3, 6, and 9. And we're summing them up. Addition is commutative, so it doesn't matter what order we add them in. So there's really only one way we could choose a set of 3 numbers where the remainders are all 0. Okay, so there's one way to get a set of numbers where the remainders are all 0. Okay, because it's just 3, 6, and 9. So it doesn't matter what order you choose them in. So another way that we could get a multiple of 3 would be taking something with a remainder of 0 plus something with a remainder of 1 plus something of a remainder 2. Okay, that would be like this case over here. We have 6, 7, and 8. Okay, so now the order doesn't really matter, so I'm not going to do all the cases with all the arrangements of, we could choose the one with the remainder of 2 first, and then choose the one with the remainder of 0, and then choose the one with the remainder of 1. It doesn't matter what order we fill these slots because the addition is commutative. So essentially we have 3 choices for numbers with a remainder of 0. Okay, and then with a remainder of 1, we've got 3 choices there, and we've got 3 numbers with a remainder of 2, right? 8, 5, and 2. So so we end up with 27 ways where we can choose 3 numbers such that the remainders are 0, 1, and 2. Okay. Alright, so let's look at another case. Let's look at if we choose them all so they have a remainder of 1. So every number is a multiple of 3 plus 1 left over. Okay, so if you have 1 left over from each number, add up those leftovers, you get 3. So the whole thing will end up being a multiple of 3, because we'll have a multiple of 3 plus 3, which will be a multiple of 3. Okay, so, alright, we only have 3 numbers that have a remainder of 1, 1, 4, and 7. Okay, so those are the ones we have to choose, so there's only one way. We could also look at the case where we have choose numbers where the remainders are 2, and we've got 3 of them. So if we have 3 numbers with remainders of 2, we're going to end up with those remainders are going to end up to 6, and then our whole number will be a multiple of 3. Okay, and we only have 3 numbers that have a remainder of 2, right? 2, 5, and 8. So there's only one way to choose that set of numbers. All right, and that's it, right? We can either have 3 with a remainder of 0, 3 with a remainder of 1, 3 with a remainder of 2, or we have the case where it's 0, 1, 2, or in some order. Okay, the order doesn't really matter because addition is commutative. So let's add this all up. So we end up with 3 plus 27, which gives us 30 ways that we can choose 3 numbers where the sum is a multiple of 3.